Hi, we're going to do the lab percentage of oxygen in a chlorate. This lab experiment is being done virtually. This is the apparatus that we'll use. You can see that we have our ring stand with clay triangle and crucible. On top of the ring stand with a Bunsen burner underneath, strikers ready to go, and we'll be recording measurements via the video to do this lab. Calculations will be completed and submitted to class. We're at the balance. We're going to be taking a crucible and putting it on the balance that's been zeroed. Your first data point to record is on the screen. The units of this number are grams. To the crucible, I'm going to add between 1 and 2 grams of the unknown chlorate. It is a white crystalline solid. One scoop is all it took. Here's the mass of the crucible with the unknown chlorate. We're back at the heating apparatus. We've got a crucible containing some unknown chlorate. We're going to put it over the Bunsen burner heat, turning on the gas, lighting the Bunsen burner, and using a gentle flame adjusted so that it's heating the bottom of the crucible. We're going to allow this to heat for several minutes. Our goal is to get the reaction to take place, which involves removing the oxygen gas from the chlorated compound. It's been heating for a few minutes. I'm going to take a look inside the crucible. The powder is just covering the bottom of it. Might be difficult to see on the video. And what I hear is a bit of a crackling sound. We're going to allow this to continue to heat until the reaction stops. We'll take a look at it again in a few minutes. It has been 5 minutes of heating. The popping sounds are still occurring. There is no evidence of chemical on the countertop, so the heating has been gentle with a moderate flame. The holes of the Bunsen burner, also known as the air ports or the air holes, are closed, and you might not be able to see it, but there is no inner blue cone with the flame. We're going to continue to heat it because if it's still making a popping sound, that means it's still releasing some of the oxygen gas into the atmosphere. We'll check back in a couple of... It's been heating for about 8 minutes at this point. If you look inside, you'll see that all of the chemical that was crystalline before is now molten. The popping sounds have seemed to stop. We're going to increase the intensity of the flame by opening the air ports on the Bunsen burner. With the intensified heat, you find that the molten chemical, the chlorate chemical that contains chlorine, oxygen, and some metal, has been heated to the point where it is in its liquid state. We're looking now at the intensified flame on the Bunsen burner, and when we look in at the chemical, we see that it is all liquid. At first, there were some small bubbles coming through the liquid. Those bubbles were oxygen gas being released from the chlorated compound. The reaction seemed to stop. We're turning off the Bunsen burner and allowing it to cool. We're going to leave it cool for about 2-3 minutes. The crucible has been cooling for about 2 to 3 minutes, and I noticed a crackling sound. What's happening is the molten chemical is cooling down and solidifying. The cracking sound that I'm hearing is the crystals forming in the hot crucible as it cools. Next, we're going to take this cooled crucible, still a little warm, so we're going to use crucible tongs. We're going to take this over to the balance and weigh it. The heating continues with an inner blue cone. If I look inside the crucible, I can see a lot of little bubbles of gas emanating from the molten salt. This chlorate is releasing its oxygen gas from the chemical compound. The reaction looks like this. Chlorate undergoes decomposition, where X represents an unknown metal. ClO3 is our polyatomic ion group called chlorate. The triangle above the arrow represents heat. When the chlorate compound is heated, it creates a metal chloride, no oxygen, and the oxygen gas goes out into the atmosphere. Write this equation on your paper. After significant heating, I actually needed to heat it a lot more to get it to where we needed it to be. I've cooled the crucible, and we are weighing it after what ended up being about 25 minutes of heating instead of just 10. I've changed the lab technique. Please write this down as the mass after the first heating. Going to reheat the crucible with using an inner blue cone for just a couple of minutes to verify that all of the oxygen has been removed. We'll take a look at the chemical. I'll put some still photographs in the assignment as well, so you can see what it looks like. After 2 minutes of heating, I'm going to turn off the Bunsen burner, allow it to cool again, and take the mass. After allowing the crucible to cool, after a 2-minute reheat, putting it on the balance again, this is the amount of, or the mass of the crucible after the additional 2 minutes of heating on your data table. And now it's time for calculations. We're trying to find the percentage of oxygen in a chlorate. To fill in line 3 of your data table, you took 2 numbers that you had for the mass of the crucible and the mass of the crucible with the chlorate and subtracted them. We verify the completion of the lab using line 4 and 5. And subtracting those, we figure out that the difference is less than 0.025 grams, so that's how we know that we are finished with our experiment. And now we're ready to use line 5 and another number from the data table to figure out how much oxygen was driven off the original sample. Show that subtraction problem at the bottom of your page. Finally, to finish the front of the lab, we're going to figure out the percentage of oxygen in the chlorate using the mass of the oxygen lost from line 6, you found by subtraction, and that's from the beginning of the experiment, and divided by the mass of the chlorate you have in line 3. So number 6's answer divided by number 3's answer times 100 will give you the percentage of oxygen in the unknown chlorate. To finish the lab, you're going to work on the back of the lab paper. The chemical we were working with was the unknown chlorate of potassium chlorate, now known to you. You are to follow the steps on the back of your lab paper or page 2 of the document. First, show me the work for the molar mass of potassium chlorate, where you have 3 elements: potassium, chlorine, and oxygen. After figuring out the molar mass, you're going to calculate the percentage of oxygen in KClO3. You'll be using 2 numbers from your molar mass calculation in a ratio, part divided by whole, times 100, to get the percentage of oxygen that should be present in any sample of potassium chlorate. The final calculation that needs to be done is the percent error calculation. For that, you're going to take the known answer from the molar mass, from the percent oxygen calculation on the back of your paper, and subtract the lab percentage of oxygen from the front of your paper. That is subtracted and divided by the known concentration or percentage of oxygen, and that gets multiplied by 100%. Percent is a unit, not a key on the calculator. Then I'd like you to list the sources of error. Sources of error would be places where we could have lost chemical within the experiment. I will remind you that I was heating for an extensive period of time, and while I was heating, some chemical came out onto the countertop. I don't know if you can see that very well, but there's a dusting of white chemical across the countertop. So some of it comes out just from the heating of the crucible on the clay triangle, and this was one that took a lot of time heating. This is one of the reasons why we're going to be doing this as a virtual lab. I did not have it filming the entire time I was heating, but I did heat it sufficiently to get all of the oxygen out. Consider some other places where we could have lost chemical in this experiment.